Right, so next is explain BGP route dampening mechanism and its use cases. So let's say, for example, we have a certain network running behind this router, or multiple networks are here, network A, B, and C. These prefixes are being advertised via border gateway protocol to the next router. From here, it is being advertised to outside network to variety of. Now the point is, everything is working fine. We can do ping, trace, and everything is okay. Suddenly, what happens, due to any reason, this prefix starts, like this subnet starts flapping. This prefix is flapping. This subnet, this network is basically coming up, going down, coming up, going down, again and again. In every, let's say, for example, 5-10 seconds, the subnet comes up, goes down again and again. Now the problem is, anytime the subnet goes up or goes down or comes up, this device is going to generate a BGP message. That BGP message will be sent to the next router. From this router, it might be sent to the next devices such as ISP, and this update might flood in the entire network on the internet as well. So if, like, repeatedly, if the changes are happening, subnets are coming up and down, it will have a lot of like negative impacts. It will impact the network stability. This change, the link has come up or gone down, this will ripple through the entire routing table of the internet as well, which will again cause high CPU utilization. It might cause high CPU utilization and resource utilization as well. So what I want only when the subnet goes stable, only then this prefix should be advertised to the neighbor router. Otherwise, this should not be advertised to the neighbor router. So what we can do, we can enable this feature referred to as BGP dampening. BGP dampening. I can enable this concept called BGP dampening. Once we enable the BGP, it takes some time. Once we enable the BGP dampening, it will take some time. But once we have enabled the BGP dampening, what will happen? Let's say this subnet is up. All these subnets are up. Prefixes are getting advertised to the next devices. Everything is okay. Let's say, for example, the subnet has gone down. That prefix will no longer be advertised to the next routers. But this router is going to create an entry. This router is going to maintain this information that the prefix has gone down. This prefix, once it goes down, this prefix has gone down, it will be imposed with a penalty of 1000. A penalty will be added onto this subnet. As soon as it flaps, a penalty is going to be added onto this particular subnet. A penalty of 1000 is going to be added. It is just a numerical value. It just represents a penalty being imposed onto that particular subnet. Okay. Then this penalty keeps reducing gradually throughout the time. So it is 1000 now. After some time, it will be 997, then 996. It will keep decreasing, like, gradually throughout the time. Now again, after some time, the prefix came up again. The advertisement, the router starts advertising that prefix to the neighbor router. Everything is okay. Again, this prefix has gone down. Once this prefix has gone down, this device is going to add the penalty by 1000 again. So penalty became like 2000, not exactly 2000, because this penalty was reducing gradually. So might be like if the penalty has been reduced to, let's say, 998 or 991, whatever. So the overall penalty is going to be 1991. So the penalty will be added by 1000. 1000 will be added into the penalty. Okay. Again, this prefix came up, advertisement. Again, the routers started advertising the subnet as it is to the next router. Now, next time, as soon as this subnet goes down, let's say this subnet has gone down again, this router notices that the subnet has gone down. It is going to again add the penalty. It will increase the penalty by 1000. Again, as you remember, this penalty will keep decreasing throughout the time. So there are chances that this will be like whatever, like you can consider whatever. Now the point is, after this much, as soon as the penalty crosses 2000, once the penalty, I'm specifically talking about Cisco devices. So when the penalty crosses the 2000 limit, even though this prefix has come up again, the advertisement of that prefix is going to be suppressed. Advertisement of that subnet is going to be suppressed. Advertisement of that particular subnet is going to be suppressed due to dampening. This prefix is basically damped. Now the router is going to wait. Router is going to wait for this penalty to go below a value called reuse limit. This is a value. This is again the value. Again subscribe as it is 750. So it will now wait. It will wait for the penalty to go below 750, and as soon as, let's say, penalty goes to 750, then this prefix can be re-advertised to the neighbor router. So here we have this suppress penalty. This is what this 2000 value is what we refer to as the suppress penalty. Means if the penalty reaches to this value, the advertisement of that subnet is going to be suppressed. And every time a subnet flaps, a penalty of 1000 is actually added. There is also this thing called reuse limit. Reuse limit basically means like once the advertisement of that prefix has been suppressed, in that case the penalty must go below this value, then only the advertisement will start again. Other timers are there as well, such as half time, max suppress limit, like for maximum how much amount of time the prefix can be suppressed, then also those things of course are going to be there. But overall the concept remains the same, that I'm only going to advertise the routes that are stable. I'm not going to advertise the routes that are not stable. So configuring this route dampening will improve the stability of your network. It will only advertise those prefixes that are stable. It is going to suppress the advertisement of flapping prefixes. It will reduce the CPU and memory utilization, because since the changes, if the link comes up or goes down, if the subnet comes up or goes down, the advertisement is not going to go through the entire routing table if the advertisement has been suppressed. So unnecessary CPU utilization or memory utilization will not be there. Routes are not going to ripple through all the routing tables of the router, or the route oscillation is going to be like reduced as well. And of course convergence is going to be improved, like devices only need to converge when the advertisement has started. After that, every device can recalculate the routing table BGP table, but since the prefix has gone stable, the advertisement will not be there, right? So these are some advantages. These are some advantages of using route dampening in our network.